Before going on to the video, let me introduce myself to you real quick. Hello, my name is Anshul. I'm an electrical engineer. I like to explore and learn new things. YouTube is the new thing that I'm exploring and learning these days. Apart from this, I like gaming, reading books. Currently, I'm studying and preparing for engineering service examinations, so you guys can expect video of any of these above mentioned things. With no further ado, let's just jump onto the topic.
Ever since the day that you went away, you've been sending flowers to me, flowers today.
Hello, welcome to another lecture of control system. Today we'll be learning time domain response analysis. Time domain response analysis is done only for stable system. It is not like it can't be done to any other system. Simply, it makes sense to do for a stable system because at the end of the day, it is the stable system that we are going to use. So what is response? Response. It is nothing but output. It is kind of output. To get output, we need input and a system. And to analyze, we need to know which input and which system. Input can be impulse signal, step signal, ramp signal, parabolic signal, or sinusoidal signal. By default, we take signal to be unity, take input as unity. Unit impulse, where area is unity. Unit step, where amplitude is unity. Unit ramp, where velocity is unity. And unit parabolic, where acceleration is unity. For first four, that is impulse, step, ramp, parabolic, time domain analysis is done. For sinusoidal, frequency analysis is done. That is, any signal in which we won't get idea of frequency, there we apply time domain analysis. Of course, by Fourier analysis, like take this system. This is nothing but simple impulse signal. After Fourier transform, it is something like this. And now you will say it is a frequency domain signal, therefore a frequency domain analysis should be done. So we should note that without applying Fourier transform for a given signal, if we are unable to say anything about frequency components, then it's a time domain function and time domain analysis is done. But mainly we take impulse signal, step signal, parabolic signal for time domain analysis and sinusoidal signal for frequency domain analysis. Frequency domain analysis we'll be learning later. Getting back to time domain analysis. Why are we talking about only above four mentioned signals? That is, why not about other time domain signals? Time domain is applied only for stable systems, as discussed earlier. How do we know if a system is stable or not? What is stability? Stability is the ability to handle or absorb shock. If shock appears and if system survives to it, it has stability, else not. So, impulse response determines stability because, as we have discussed earlier, impulse represents shock, unit step signal represents position, ramp signal represents velocity, parabolic acceleration, sinusoidal oscillations. That is, impulse signal represents or determines stability, and remaining three, that is step, ramp and parabolic, represents ability. Like while judging a student, we first see if he or she has passed or failed in an exam, and then we go for the marks obtained. Similarly, in a system, we first see if system is stable or not, and then we go to check ability. That was all about which input. Now, which system? Nature of system response depends upon poles of it. According to number of poles, the order of system is decided. That is, order of system is equals to number of poles. Order can be first order system, second order, third order, fourth order, etc. Minimum order is first order system. We are going to analyze first and second order system completely. Analysis of third and fourth order will be done approximately. Why? Because for analysis, as the order increases, complexity increases. That is, difficulty forming partial fractions and then taking Laplace transform of it. With using only pen and paper, it's complex. Use something like MATLAB, it will do even the 10th order system in few clicks. Moving on, how third and fourth order are analyzed approximately, you ask. Third order system is taken as first and second order system by simulation method. Fourth order system is taken as two first order system and one second order system, or two second order systems. It's 90% accurate.